Hi everyone, 大家好. I'll be going over some of my slides from Taipei. So yeah, let's get started. So this slides are available on Speaker Deck under like my page. So it's just a kind of a high level talk about PureScript and some of the things that I think are interesting in it. So in the conference, I just went over some of the introductions that people wrote for me, and like this like really silly meme over here where the guy like purposely hurts himself and says the types are a lie. So yeah, so the way that this conference worked was that well, it was just like dual track, and one track was like primarily programmers. So there was a talk done by CT Wu in the morning, and it was in Chinese, but he went over a bunch of stuff, kind of like the normal PureScript introduction, but then he also talked about a bunch of co-mounted UI stuff. But yeah, so what I tried to talk about in this talk was I just wanted to talk about like generally what PureScript is, not like actually a lot of the specific details. And I wanted to talk about like some of the interesting ideas, some of the interesting things in PureScript. So when I say like some of these ideas overlap with Haskell, I mean that like well, yeah, like most of the ideas overlap, but then some of the obvious ones like row polymorphism and some of the ways that relations work and such, it's like quite different. And well, obviously PureScript is going to have a eager evaluation, which is usually more painful than not, but it is something that's quite different. And some of these ideas like refinement types and such, like they're shared with Haskell, but then they're not really that common in other languages. So one of the main things I also wanted to show off was that the computer can do a lot of the repetitive and error-prone things for you. So like typically, like when you deal with what kind of solutions that other people give you, you end up with some kind of like boilerplate generation, right? So instead of dealing with some kind of horrible string generation or AST generation, I wanted to talk about things that were actually first class in a language that is driven by types. So I'll go into more stuff like this later, but then one simple example would be like simple JSON or something. So yeah, and I really wanted to get people to just like get some kind of like teasers for PureScript. So I really hope that people got excited to learn PureScript. Someone told me that later they got some feedback that other people did want to learn PureScript after seeing my talk. So that's a good thing. But hopefully more people want to see it after seeing this recording also. But yeah, what is PureScript, right? It's a language that's similar to Haskell, compiles to JS. And there's a lot of different details. Some of the also it's because it came later, so like Prelude doesn't have partial functions and that kind of stuff. This is just stuff that comes out of a later implementation. And one of the big things also, I guess, is that like Prelude. Oh my god, I can't even write on this thing. But yeah, like Prelude doesn't come with PureScript, right? Like that's just not really a thing. Like a Prelude is a separate library, so you can choose to write very minimal PureScript where you just kind of FFI binding like some of the few things you need, and then you mostly work with like your own Prelude that you might define, right? So that's something that's kind of interesting. Some of the interesting newer ideas, yeah, like this would be like row polymorphism or like instance chains, that kind of stuff. One of the big things I wanted to highlight was that it's not like an annotation-based language, right? So it's not like TypeScript where you had these type annotations where everything is kind of unsafe coercion. So if you say that a certain value is going to be the union of number and int or number and string, then there's actually no real validations on that value, right? And in TypeScript, you would then use these type guards instead of actually being able to match on any kind of data constructor to say, okay, now that I've checked for this not being a number, remove the number from the members of the union type, and you get like string back for like the actually like refined in quotes type. So instead of dealing with those kinds of like type guards, which actually aren't very easy to understand either, you just have like these first class types, right? So that's what I wanted to talk about here. And the most important thing was that when you have small bits of fundamental information, just even the most basic things like some type of an int with int in one of the branches, like you actually can know for sure that that value is there. Whereas in my experience, writing TypeScript has been that even if I put a type to something, or if someone else puts a type to something like definitely typed or whatever, it's usually not going to be the whole truth. So no compounded information actually doesn't give you any kind of guarantees in TypeScript. So this is what I want to talk about here. And yeah, like giving you tools to encode more information in your code base. This is like more something I'll go more into, especially with like this quote of like make invalid states impossible. But just the idea that you might start from having simple type aliases and then you go to like refined types or something. And yeah, I think one of the big things that I really like about PureScript is that we had this culture of like sky's the limit, right? So you can start small, but you can always improve whatever you're doing now, and you can always like go to the extremes if you want. It does depend on you knowing enough about how to do something, but nobody really will tell you that you shouldn't do something. So I think that's great. And like I think the most obvious example of this would be like all the like roll-to list stuff you can do. Like nobody's going to tell you like that's pointless. Everybody's going to say like, wow, that's cool if you do it. Or at least I think that's the case. So the first part of this talk is talking about this make invalid states impossible thing. So it's like a really famous mantra that like a lot of people like to repeat. I think it's like really popular to say in like the OCaml and Elm worlds, but I think part of the problem is that like a lot of the ways that this is presented, it's almost like some kind of a dichotomy. Either something is safe or it's completely unsafe, or it's like completely invalid or whatever. But I think like in reality, like the way that we program today, it's not at all binary property. So you actually have to choose how much you buy into something, right? And a lot of languages don't actually give you enough power to do this. So like say if you wanted to store a refinement information in a type level collection and be able to actually get routines derived for that to check stuff, then like you just can't do that. And I'll go into the next slide where this is something that like we do in PureScript if we want. So like really like this is a spectrum. So I really hope like people start understanding that like nothing is actually like a silver bullet. You actually just accumulate whatever properties you actually want to check for. So the most basic example would be like using a type alias. So this is quite convenient. I think it's not like so wrong, but if you have type URL equals string, then if you define a function that takes in URL1, you can always pass in like any old junk. So this is like it's the most convenient thing to do, and I see it a lot, and I do it also a lot, but it's really not good for safety. Like you can always make like an IO action that always like fails, right? But then that's kind of useless. Like if you have some code branch that always goes to the failure branch, I think that's fairly useless. So the next part would be like a new type, right? So this is quite popular. I do it all the time, and it's the problem with new types is just that it's only as good as your constructor being available or hidden, and only as if your constructor is hidden, then it's only as good as your validation function, right? You have to write some kind of term level function where you hope to God that you did the right thing, and well, maybe it won't be right, but who knows? And the third thing I want to talk about here was refinements. So like say if where the constructor isn't exported, right? So you can do some kind of validations at the type level if you want. So I think one of my favorite examples for this would be my like home run ball library, where I did the structural subtype of validations. So I had this data has @ and data is JL. or it is Gmail, and these are type kinded, right? And so if I make a type that has the validations in row type, then I can work with the unordered collection of validations that have been performed, and I can basically write functions that require this substructure. So almost this, well, the exact same as an extensible record function. And I can also do some type level things where I can use row list to iterate over and say, just check this and then check this, right? Or, and whatever concrete type is available, I can further do more work there. So yeah, what is this like pound type, right? For people who don't use PureScript, they're not going to really know what this is. So pound type is a row type of this type, right? So this pound takes a type parameter and gives you back out a type. So if you think about how the records work in PureScript, they have statically defined fields with static label names, right? So you always know like what keys exist in a record. They're heterogeneous, so not every value in a record is the same. And each field will always have the correct type associated with it, right? So if I have like apple and int, if I have an instance of or if I have a value of my record, I will always have an apple field that's int. And that's actually like, for people who have been using languages like this for a while, they're going to say like, of course, but this is actually quite new. Like it was even quite news to me when I came to PureScript from like a JavaScript background. And yeah, and they might ask like, what do you do about optional properties? And the most like common answer would be you can use maybe. And then you'll actually have this explicit nothing and just states that you deal with. So this connects in that the fields syntax, this curly brace syntax is actually sugar for record, right? So if you look at the prim module, so the built-in compiler module, you'll see that record takes in a row type of type argument and gives you back a type, so that the same my record that we have back here using curly braces is equivalent to the my real record here that takes in a row type of the same fields. And then we could also like reuse this same information. Like say, if you're familiar with the PureScript variant library, then like you can make a variant of this, and you could also use it to say, I want to update any field that exists in my record, but then I want to be able to like set up the code path like statically, and you might use this. So the other part of this making invalid states impossible thing I want to talk about was just sum types and cardinality of data. And by cardinality, I just really mean the most simple thing, like your middle school math where you play some dice games or whatever, and you just say, okay, what kind of states actually are like going to exist, or how many like permutations do I have to deal with whenever I deal with my thing? So if I have like interboolean, then I know that it could be one side where it can be an n number of values for the int, or it can be just the boolean where it only has true or false. So I know then here's just 2. And so there's like n plus 2 like combinations of things I have to think about, right? Just like just think about this in the most basic terms. And it's the same thing for the records, where you have 2 independent values that are grouped together. So it's going to be the number of possible things you have to deal with is going to always be this product here. Well, and that's why it would be called summary product type. And also another important thing would be that you actually have this case where you just have a constant value, right? So this is isomorphic to maybe, right? But it's quite important to note that like we can actually model this instead of using like null or undefined to try to model the case that doesn't exist. And continuing from this, I want to talk about like if you're dealing with a record but you want to deal with it as like a collection, then maybe you are using a homogeneous map. But then vice versa, if you try to map something as, if you try to model something as a map, but you actually do know like statically what keys are there and it's supposed to be heterogeneous, instead of doing some kind of awkward homogeneous map where you have to then match for a specific key having the specific type inside or in specific value inside, we can just use a record here, right? So this is something where, like, at least I also ran into this, that I would often use maps when I actually want a records and vice versa. And it's like a important thing that we always kind of brush over because it's the like basics, but basics are important. But yeah, that's like the first part of this talk, and like the second part is actually about types not being just for checking your work, right? So a lot of people think about types only being like kind of a handicap for you to write whatever you actually want to write. But the most like easy example of this would be that decoding JSON should be free, right? So if you write an actual static type out, you already have some static information that you want to work with, so you actually know already what the keys should be and what the types associated with those keys should be, so that, like, say if you have a record type my JSON here, if you know there's a field apple that should contain string, and banana that should contain int, and cherry that should be a maybe boolean. So in this case, the encoding just being that maybe is going to be null or undefined. Like, you should be able to get this for free without writing the boilerplate that's actually not just boilerplate, because it's actually decoding parsing code that's very error prone. So like, say if you just wrote this by using a get at a certain field, like with string value apple, right? Then this has like a quite big probability of failing, because like with boilerplate, if you just write this by hand, you'll end up copy pasting a lot of stuff and you'll get the field names wrong. Or if you try to use some kind of IDL and try to code generate this boilerplate, there's still going to be parts where you inevitably there's some mistakes made about how to edit this. And it's also something where in your programs you don't actually have a true mapping a lot of times between your domain and your transport. So instead of trying to put it all into one awkward bit where you try to define a bunch of concrete functions for how things should be parsed into your domain type, I think it's actually quite important to separate out your transport types and your domain types. But it's really up to maybe somehow up to preference. But there's actually more about this I've written down in some notes for some docs for simple JSON, so it might be worthwhile to go visit the simple JSON documentation. But yeah, just like I have a very simple examples here, right? So if I pass in a JSON string that's going to be apple red banana 2, then I can use my decode to JSON function, which is just an alias for this. So you could just use simple JSON read JSON here instead. Just put this here just for easier demonstration sake. And then, so since this one is valid, then it'll actually come back on the right side to the either, right? So the right side being my actual value. So here I'll come back at right, apple red, banana 2, and cherry nothing, because cherry is undefined. And in the second case, I have improper data where I have apple red, banana wrong. And so this was supposed to be an int value. So then what we'll get is we have an error at the property banana where there's a type mismatch of int and string. So how does this actually work, right? The way that it works is that we can define type-driven programs. So simple JSON and a bunch of other libraries use these type classes, right? So, you know, as much as like people like to complain about type classes and whatnot, like in actual real everyday usage, it's quite useful, right? Where you can say that, okay, so I have a class read foreign that has a single parameter in this case, where there's a method associated called read impl, right? So I can know that if I deal with any type and I use this constraint, like back, it's not actually here, but like say if I have a signature for a function, and I have like f is going to have a read foreign constraint for a, then I know that like whatever a I pass in here to this function is going to be in the set of types that have an instance for this read foreign. And it's like quite a powerful assertion about types that you can make here that isn't necessarily so reflected in a lot of languages. And of course, it's not even just like simple single parameter cases, right? Because we see that when we want to actually deal with records, then we destructure out the record constructor with the row type parameter, and then we can actually use this row to list type class to say that there's a relation of a concretely available row type to the iterable list that you can derive from it. And then there's a relation where you can read the fields by iterating this list, starting from an empty row type to build up to the complete row type. So there's multiple parameters with functional dependencies to say which parameter matters most and which ones are going to be fulfilled or determined by this. That's actually quite a powerful thing that's missing in a lot of languages. And that's like something I wanted to illustrate here just very briefly. So yeah, hopefully like less people try to just say that type classes are useless in the future. Maybe, I hope. But yeah, what is row to list, right? So row to list is a feature that we released last year in PureScript 0.11.6. So it's the idea that like if you have the static type row type information available, then you should be able to turn it into an iterable list at the tail level and match it to instances, right? So a row type, if we review real fast, it's that there's actually no order involved here. So if you have field A of string and B of int, that's actually equivalent to B of int, A of string, right? So this is completely unordered. But then by turning it to the iterable list, we force some kind of ordering on it, where in our case, with row to list, we enforce this alphabetically ordered keys. So like both of these would give back out this cons of A with string with another cons inside for the tail of B and int with nil, right? And I think this is like quite a powerful tool. So it's like there's this big parallel, right? So we can say like we can define a 2RL proxy, right? So you can pass in a proxy of your record type, and using the row type information inside, we can then use this row to list relation to get back out the row list and then give you back this row list proxy, right? So in the runtime, it's just empty, but we can actually use this information to like derive routines. So say like if you have row list my JSON, then like, you know, if you do RL proxy on my JSON, you're going to get this cons apple string, cons banana, int, cons cherry, maybe boolean, nil. And we can actually match on this, where by writing the is instances for the cons and nils cases, we can determine what we want to actually have done. And there's something I also wrote about the other month called I think I called the blog post type classes and instances are pattern matching at the type level. So just talking about how there's a really clear parallel here between this code and your typical like case excess of, and then like cons x and nil, right? So this is like these are like quite similar, like, and like I don't know, I think maybe the term might be like there's like some kind of symmetry between the kernel level and type level things. So I think it's like quite interesting to think about it this way, like even from a non-academic perspective. But yeah, I mean, that's like the really big thing about like that we can program with this type level information that it's really missing from a lot of the other languages I've used in the past. So it's something that I hope people would get more excited about and like really like try playing around with it and see if they can come up with ways that they can think about how their problems currently might be solved in PureScript or other languages. Well, like you can do all of this, of course, in Haskell, but not so many other languages outside of that. Or I actually don't know of any popular language outside of Haskell and PureScript that can do this. So if someone knows, then they should totally link me if they've been watching this video. But yeah, so other examples of type-driven programs would be like I've done this type-level routing between server endpoints and front-end requests. And then so this part means that I've also done like the route handling where I ensure that each declared route in my row of routes is actually has a handler associated with it. And it's something I've also done in Haskell. So it's not unique to PureScript, right? It's like there's different looking ways of doing the same thing, like that's quite popular with like Servant and such. I've implemented like this type-safe cycle.js. So, if you have drivers, sources, if you're somewhat familiar with cycle.js, basically the way that works is that you have a main function where you're taking a record of sources that you're working with and you return a record of syncs. And for each label in your syncs, it calls a driver that's associated with that label, runs it, and then gives you back the source. And then those sources are actually collected back into a record to send back to your main function, right? And this is done with some proxies. So this is like also quite a fun thing. And I use this quite often for like chatbots and such. Refinement types I've already talked about, kind of up there. But like the whole like home run ball library uses row types to do some quite ergonomic refinement types. So this is something that like also there is like Haskell versions for, but I've never used the Haskell ones because they're clunky. Decoding INI files, it's like the same thing on simple JSON. And I've done a talk about this also like in New York and also here in town in Helsinki. Diffing two differently typed records. This is also something that I've done where doing some typable stuff to figure out like what fields are intersecting between two record types, and then like just taking the diff of those of the same fields and then returning some kind of a list of variants of like the things that have been different. And like of course like exhaustively matching on polymorph variant members, it's like a really nice thing that like the variant library has this match combinator, and you can provide a variant, and then for the same labels you can, and the same labels and values, you can provide a record that deals with those values. And yeah, it's just like really nice. And yeah, there's just like so many more things that are possible with this static type information and type level programming, right? So if we look at like type synthesis with like other type information, this is something that's like new to PureScript 0.12, where I had this static string, and since my static string compares like these contains these parameters, and they have this dollar token, then I can actually parse this type level string and get this out, so I can create a record type and that has these labels, and I can use this to actually extract out the type information here, right? So I think this is like really cool, and I talked about this in Milan a couple weeks ago, so really hope like people also check this out. Like I mean, my implementation is like kind of crude, I guess, in some ways, but I do use it at work also, and I hope like more people try fiddling with stuff like this. But yeah, I mean, this is just the tip of the iceberg, right? So like everything I've shown here is probably like what 10% or less of what PureScript community has done. So really, I'm just like mostly talking about things that I've done or that I've looked at, but I still don't know like what everyone in PureScript has done, and I think that's actually quite cool. Like if I like often I don't have solutions for things, so I can always ask other people to give me ideas or to let me know like how they've solved problems. And I think that's like quite cool that in such a small community we have a lot of people who are like quite experienced with a lot of different problems that they've been solving. But yeah, my takeaway for this talk really is just that people should learn PureScript. right? I mean, so even if you don't use it just for fun, but there are like lots of ways to use PureScript, right? Like if you want to use an existing project, you could make some small modules that you import in. You could use like React Basic if you want to do some basic React interop. It's actually not so basic, like it covers quite a lot of the React API. But yeah, and then there's also like the idea of like hoisting PureScript in JS or JS in PureScript. So like, if you wanted to run PureScript on the AWS Lambda or whatever, you could hoist PureScript inside of JS, like um, just some JS boilerplate that hooks up some things or starts like the Express layer or whatever. Or like you could also just make some small applications with existing libraries. Like so for front end, I would definitely just say like everyone should just use Halogen because it's the most complete solution. But there are like plenty of other solutions that people can use, right? But unfortunately, it does require a lot of upfront investment, right? It's not like so much, but you definitely have to do a lot of reading and some practice problems, and you have to look at some core libraries and how they work, like PureScript effect. That's like just inevitable that you have to learn a lot about it. Um, but there are some things that are actually like instant feedback, right? So if you learn a bit about the FFI and how it works, because you can directly call JavaScript instead of dealing with some kind of a transport layer or some kind of a imposed architectural system, you can really readily just learn a little bit about FFI and write whatever, right? So at least in my case, like when I started learning to use PureScript for real about like 2.5 years ago, I wanted to write a chatbot. So like just learning about the FFI immediately paid off and let me write a chatbot like within a day. So I think it's like quite useful, but it does require like that you at least like learn more than the typical languages. And it's also the problem that like we kind of a culture problem where most of the time when people learn new languages, they usually learn a lot of the same old languages. Like going from Ruby to Python isn't so much of a shift at all. So it really will be like quite different if this is the first time that someone's using a new language, right? And it was also the case for me where like before using PureScript, I had used Elm a little bit, but most of my time was spent finding the ports and trying to just get ports to work. And I was mostly interested in the reactive parts because I was also quite a big RxJS user. But coming into PureScript, it was the first time I actually had to learn like what a sum type was, what constructors were, what actually was a type, what was a kind, and that kind of stuff is like it's stuff that you don't necessarily immediately need, but you do have to like learn a lot into it. So unfortunately it is quite a investment to try to learn how this stuff works. Not that it takes more than a couple months, but a couple months even still does feel like quite a long time. And yeah, because PureScript is a small language, it requires some community engagement, right? So if you don't have anyone who's like involved with PureScript or the PureScript ecosystem in any way, then adopting PureScript can be like quite difficult. But luckily, there's like a lot of resources, right? So you can always ask questions in various places. At least if you're in Taiwan, you can go to purescript.tw. So it's a Facebook group run by CT and some other people. So you can always ask them like, hey, how is using PureScript, and like how should I get started, or what kind of things should I read first? There's the discourse where we have like a forum and you can ask questions there, and it works. There's like the Slack on PureScript and PureScript behaviors on FB Chat. So if you use Slack and you like using Slack, you can always ask questions there, like especially any kind of like temporary like small questions you can ask there. And yeah, I mean, like you can also ask me questions like I like yeah, I'm fairly often on Twitter. I can't answer literally every question, but at least I can help like link people to different resources or link people to some of my other posts. And I think by now I have like so many posts that like it shouldn't be too hard for me to give you a link to something that I've already talked about. But yeah, this is like the end of the talk. So this is like it for what this slide was. And unfortunately, let's see. Yeah, there you can see the last page of this thing. But yeah, this is just a quick walkthrough of the stuff that I talked about in this talk. And yeah, it's really nice to go visit Taiwan. And I hope people watching the recording aren't like too bored. It is 35 minutes though, so I don't blame you if you close the video at like 2 minutes.